Okay, it's time. We will start with the presentations of the projects, and I will give you another challenge. It's not even 2 minutes, but 90 seconds, given the time and the switching. We decided to give every speaker 90 seconds per project. Please indicate if you have more than one project to present in your slide desk. You get a double of time, of course. Right, I will share the screen and you see your name. You can also see who's up next in Meet Echo if you want. All right. Okay, first presenter is remote or here in the room? It's transaction token profiles for A2A calls. You want? Yeah. Oh, well, oh yeah, yeah, I do have. That's easier maybe. Oh. Give it a try. Maybe I switch on. That's another thing inside. Yeah, there it is. Yeah, okay, success.
Thank you, Benno. Hi, my name is Peter. Happy to be the first one presenting in the afternoon. So this time we're presenting a transaction token profiles for A2A calls. So the background is actually we have, the OAuth working group has a transaction tokens draft that can securely propagate user identity and authorization context across workloads and workflow, and eventually will service a workflow. And transaction tokens will actually define several immutable and changeable data fields. So this can help the workflow when propagated through different domains can protect critical security contexts. And sometimes in agent-to-agent call chain, you have to protect your call context, secure context, for sufficient input for the access control in other domain. So what we do is actually map the A2A message critical information such as task ID and the original user prompt input into the immutable perp data field defined in the transaction token document. So actually, this is supposed to be immutable, and this can prevent new attacks such as prompt injection and intent manipulation and context rot, those kind of attacks. And during the process of a A2A call, actually the downstream agents would do some additional inference and add to the context. So you have a, sorry? Okay. So we don't have a timer, so I can't see the time, but eventually we did a code here and connect the inputs and outputs. There's no timer. All right. And eventually, I think this reveals a little bit more profound questions because A2A is envisioning a more collaborative future, but actually poses more security exposure on your internal resources. And this also, the attack is becoming more implicit because currently traditionally we do contextual, header-based threat detection, but now the attack is more inside of the payload, inside of the prompt. So I think we need to consider all these different questions, and we arranged a Thursday 11 to 12 AI agent security site meeting at Hunan, the small room, to discuss. Thanks. Thank you, Benno.
Thank you. Yeah, so sorry. I don't have time to set a timer. That also takes time, so I will show time with my telephone. Next up is the next deck. Packet scope. Are they in the room? Or is it remote? Anyone remote? Join? No? Then I go to the next presentation. The generic, let's see. Oh, Thomas.
I bet. I bet. Sorry, my voice is terrible.
Oh, that's, sorry, Thomas, yours was the previous, the packet scope?
No, no, no. It's the co-serve, the one that you're showing now.
All right,
Can I go?
I can hear you. Yeah.
Okay.
I just want to make a suggestion for everybody to help Benno out. He works very hard organizing this. If you have a presentation, go to the IETF agenda page, go to the hackathon results, click on the meeting materials. You can see the list of slides in order. So look at the list. If you're coming up next, come and stand by the stage, because if we have to wait 2 minutes for people to switch, we're going to be here till midnight. So let's help Benno and move it along quickly.
Thanks. Thomas, should I give you say next slide, or you want to
Yes.
run themselves? Yeah.
No, no,
Okay.
please, next.
Good. Yep.
Okay, so so the topic here is co-serve. Co-serve is this minimalist query language for pooling endorsements, including trust anchors and reference values from the supply chain in the RATS architecture flow. It's a CBOR-based protocol that reuses much of the quorum data model. We did it as an explicit choice, of course. And quorum is another protocol that we're developing in RATS. So we're really eating our food. And the work we present here is basically brings together the server and client sides, an HTTP-based API and the quorum verifier to ensure that all the pieces fit together with RATS architecture. The next slide is exactly that picture, but I think, since we have very little time, I'm going to go through very quickly. The answer that we got from the Hackathon experiment is yes, they do. They fit all together, and this is something that we're going to bring back to the working group on Wednesday. And here in the slides, you can see a few standards that are under development that we have used, we implemented in the demo. I think I forgot to add RFC 9111, which is the HTTP caching, which was one of the building blocks for this. In fact, what we focused on here was adding the HTTP caching into the flow. And that was very easy, I would say. It required adding a crate on top of the request crate that we already used on the client side, and on the server side, sending the right cache control headers to fit the client logics. And next, please. Again, we did it basically. This is the architecture. Yeah, you can take a look later what got done. This is the list of things that we've done. We have a complete and fully functional end-to-end appraisal flow. And what we learned, a few things, but the most important one to me was that the quorum and co-serve are highly compatible. And the second thing is that HTTP caching works out of the box and is a fantastic tool if you need to add caching to your transactions. Next, please. And yes, the team members were Shefali, Paul, myself, and Henk. Shefali was a first-timer here, and there's the link there if you want to try out the demo. Thanks very much. Bye, Ben. Bye, everyone.
Thomas. Next, applying Jan.
Following the past two hackathons, we are bringing from our draft of applying Jan provenance signatures an enhanced demo following the serialization of the data format in CBOR objects. The provenance, what we are investigating is how to provide provenance to data sets and to provide data integrity to that data sets that are modeled in Jan. Some use cases can be on device configurations or telemetry data. What we brought from apart from the other hackathons is an end-to-end workflow using a Kafka message broker, where there's a data ingestion, serialization, and formatting, and several microservices doing the signer and verifier modules of these signatures that we are applying with COSI. Apart from that, that data should be validated. There is a Jan schema to be processed, this data. And this new workflow is operating with byte serialization and CBOR object management, using only binary data, using CBOR. Here are the integration details of the workflow. This is the whole workflow is serialized in bytes and encoded as CBOR objects. Apart from JSON and XML, which are the previous versions of this workflow. What we achieved here is that we enhanced the reference implementation has evolved and is aligned with the latest draft updates that are in the OPSOC working group. And adopting these CBOR data formats and the binary encoding, we reduce the message size, and it has a faster processing of this data and improves extensibility. This is also a work in progress with Jan Push and the Jan Kafka schema registry that we are using along with our Kafka workflow. And for the next hackathon, we try to finish providing a multi-signing implementation in this workflow. Thank you.
Thank you. All right. Next slide desk is from, there you go, model for distributed authorization. Yeah. And you will set the timer also. So you have the time.
Okay. Hello, I'm Lucia Cabanillas. I'm working on a model for distributed authorization policy sharing. The goal of this framework is to define a canonical way to manage and share authorization policies. We use Jan to define these policies in a much readable way. The policy logic itself is written using policy as core languages, while Jan carries this logic together with its metadata, enabling it to be validated, versioned, and distributed. This approach is designed to support interoperability across domains, while different kind of policy engines, typically PDPs, can consume and enforce the policies. So in the draft, each policy artifact model in Jan includes a description, the policy language used, the policy as code language, the policy as code logic, the owner of the policy, the version, and additionally, we included an optional provenance leaf. So to demonstrate the policy creation, distribution, and enforcement using this Jan-based model, a Jan policy artifact is submitted to a policy administration point, which is in charge of validating and distributing it to the corresponding policy decision point. What we have used is OPA, Open Policy Agent. The policy logic is written in Rego, which is a policy as code language, and we use this policy to protect some data stored in a GraphDB. Specifically, the policy denies queries requesting the consent vendor name. So to validate this, a user authenticates with Keycloak, which is acting as our identity provider, sends several requests to API6, which is our policy enforcement point. API6 query OPA to decide whether the request should be authorized or not. Normal queries return the data, query requesting the concept vendor name are denied. So with this, we demonstrated or we implemented a YAM-based policy sharing, we demonstrated policy distribution, and we validated that this approach can support interoperability and automated policy management. Next step, we would like to use some mechanisms of provenance, further explore cross-domain policy sharing scenarios, and we are looking forward to gathering feedback. Thank you.
Next. Yeah, excellent. There you go. Thank you.
Hello, everyone. I'm Guozhen from China Telecom. My presentation is Anson. Okay, thank you.
Excellent.
Yang API. First, Anson, short for Organization Network and Service Abstractions, is a working group forming both. Its previous name is Onions. The Anson working group and the Anson working group aims to abstraction implement and use, improving automation, operational efficiency, and interoperability. Yang API is a technical methodology for the automatic generation of API interface based on the Yang data model. Its primary function has 3 parts that including model parsing, model mapping, and standardization, service interface generation. Its implementation has 3 steps. Step 1, Yang model parsing and structured presentation. Step 2, automatic conversion from model to JSON schema. Step 3, generation of standardized RESTful API interface. Okay, finally, welcome to our Anson, both at Grand Ballroom 1 from 9 to 11 next Tuesday morning. Thank you.
Excellent. Thanks. Okay, next presenter. Let's see. Is that correct? Yours? Yeah? Okay, excellent.
Okay, good afternoon. I'm Nangong from Huawei Technology. I will share the results of 2 Hackathon projects. The first one is selectively syncing RPK data to routers. The problem is that current RPR protocol will sync all types of RPK data to routers, but in some cases, the router may only need part of types of RPK data, and other RPK data will never be used by routers. So our main idea is that why not only sync part of the types of RPK data that are needed by the router. And what got done? We made 2 key extensions to existing RTR software. The first is to extend the slurm mechanism. This enables the filtering of specific types of RPK data in the local cache. And the second key extension to the RTR software is that we extend the RTR protocol. It allows the router to send a newly defined PDU to subscribe the RPK data. So only the RPK data that are really needed by the router will be synced to the routers. And here are the team members, GitHub link, and related documents. This is the second project. It's RPKI-based validation with prioritized resource data. The RPKI data is not complete, and especially for the newly defined RPKI objects like ASPA, and some operators will complement the RPKI data by using IRR data or AI inference. However, as you know, the IRR data and the AI inferred data are not always correct. So the router will use conservative actions on the invalid routers. The main idea of us is to mark the RPK data and the validation results with priority or credibility, so that the router can discard the invalid rules with high credibility directly. And we have designed and implemented the algorithm. And next, we will finish the design. Here are the team members and the related document. We welcome comments and welcome everyone to contact us to work together on this work. Thank you.
Thank you. Up next is a gateway. Yeah, excellent. Thanks. Thanks for the tip, Stuart. Works very well.
Good afternoon. I'm Wei Wang from China Telecom, and today our topic is about agent gateway for dynamic multi-agent secured collaboration. And yes, the AI agent gateway is a device serves as a unified entry point and control panel for traffic, and it should support the capabilities such as discovery and registration, the routing and addressing, the gateway interconnection, and secure communication. And we also developed one demo for the multi-agent collaboration. And you can see in the figure, we have two domains, and each domain have a gateway and an agent. And the agent has different capabilities, such as the video recording, video analysis, the alarming, which can call the fire policy, and the agent to contact the homeowners, and they can collaboration with each other and complete the fire detection scenario. And we have proposed two related documents. And if you are interested in our topics, maybe you are very welcome to attend our set meeting, which will held on Wednesday and Thursday. And you can also show a post and show your ideas and comments in the DMSA mailing list. And any comments are very welcome. And okay, thank you. Thank you for your attention.
Thank you. Next up. Off. Thank you.
Thank you. Good afternoon, everyone. Today, my presentation is on OAuth 2.0 scope aggregation for multi-step AI agent workflows. I'm presenting on behalf of project champions, me and Shuping Peng, and we are from Huawei. And the background is that the advances in LLM enables AI agents to plan and execute multi-step workflows, which may involve calling third-party tools, for example, via MCP, or delegate subtasks to other AI agents via A2A. Those interoperations typically require authorization by OAuth 2.0. And consider a scenario where an AI agent connects to a notebook MCP server. The user talks to the AI agent to summarize this week's daily reports into a weekly report note. The AI agent reasons that I will first need to call list notes, then call add note. The problem is not the existing agent protocols. For example, MCP, it adopts OAuth in a reactive and challenge-triggered way. So the user needs to respond to multiple consent prompts with distinct scopes. For example, here, list notes and add notes are distinct scopes. So our proposed solution is first, the server exposes the security requirement in the resource metadata. Here, the add note has tab OAuth 2 and the scopes red. And the AI agent will initiate a single OAuth flow for the aggregated scopes. Here, read and write are aggregated. And here's a demo. We have built a notebook MCP server with UI shown here. You can see from the logs that we aggregate scope read and scope write and to form a single authorization. So we will show this demo on Monday's Hack Demo Happy Hour. We are very welcome for feedback and suggestions. Thank you very much. Thank you for your attention.
Oh, very good for the promoting of the Hack Demo Happy Hour tomorrow. Next up. LLM-driven automated. Yep.
Hey. Hello, I'm Yunze from Tsinghua University. I'd like to share our project of LLM-driven automated network protocol testing with you. Network protocol testing is to test protocol implementations such as switches and routers to ensure the conformance, performance, and security, etc. However, traditional methods are mainly labor-intensive. They are often with low efficiency and limited coverage. To address these issues, we design and implemented our automated systems that takes protocol specifications as input and generates test cases, test artifacts, and execute them in the test environment. On the right side, you can see our hardware and software test beds. Now, Chui will show our demo with you.
We select a target RFC file and the system will extract the functional modules. The system first generates test points with testing objectives, then it refines the test points into detailed test cases with procedures and oracles. Using an agentic approach, the system iteratively interacts with the environment to produce executable artifacts. Finally, it executes the test code and produces the final test report. Thank you.
We have also some related drafts and demonstrations. The draft is on Monday afternoon and the demonstration is on Tuesday. We sincerely welcome your comments. Thank you very much.
So I'm super impressed. Everybody keeps within the time. It's really good. Next one, optimizing agent.
And good afternoon, everyone. And I'm Zize Chang, and I'm presenting on behalf of the champions, me and Shu Pingpeng. I'm very happy to share our Hackathon project, optimizing agent context interactions. And so why we are doing this? And today, a lot of agent protocols like Google's A2A actually transmit plain text information. And this wastes too much tokens and cost the long task execution time. We realized we need a smarter way for agents to talk to each other, which is structured, efficient, and scales to real-world applications. Our core idea is simple. Instead of agents constantly resending plain text, we give them a structure and to help the agents to focus on the necessary information. And besides, we also built a context manager to keep track of the big picture. To test this, we picked a realistic scenario, analyzing financial reports of 7 new energy vehicle companies. And we built a small multi-agent system with a master agent and 8 specialized sub-agents. Then we run 2 scenarios, one using our structured context exchange and another using plain text. And we measure the token usage and the execution time, and the numbers were pretty convincing. With our approach, token consumption dropped by like 17% in some cases, and execution time was optimized by 30%. And we want to thank all the participants for the contribution. Thank you.
So next up, BGP flow spec with packet content matching. Yeah.
Hello everyone, I'm Yu Jia from Zhongguancun Lab, and the topic of this hackathon is extending BGP flow spec with packet content matching. And the BGP flow spec is widely used in chiral network for traffic handling or the DDoS attack mitigation. And as the traffic intensity increase, the the scrubbing center cannot defend the attack well. And also the packet capture from the operational network shows some attack have a specific payload pattern. So if we can defend this traffic in the network device through the BGP flow spec, it may reduce the defense cost. But the current flow spec only supports header-based matching, so that's why we propose the packet content matching. And this work is proposed in IDR working group, and which is eligible with the exploring flow spec v2 work. And in this hackathon, we defined the filter encoding and ordering, and also implemented and validated open source software and commercial hardware. Here is a software implementation result. The test is on the OpenBGPD and FR routing, and we test it in some different scenarios, and the code is open source in the GitHub. Here is the hardware deployment result. It works on a switch by ASK switching. And from this hackathon, we found the packet content matching can reduce the traffic processing cost, but it requires careful deployment. And here is the team member of our hackathon. And if anyone interested in this topic, please feel free to contact me. Thank you.
Next up, SRV6.
Hello, everyone. I'm Minxue Wang from China Mobile. So our hackathon project is the SRV6 for the interlayer network programming. And we defined the SRV6 and IL for interlayer working behavior to instruct a node to send packets through underlay links or connections. So here we demonstrate a multi-member interoperation with SRV6 and IL in a slicing packet network scenario and enabling the domestic connectivity to the cloud private network. So we validate as SRV6-based EVPN service connectivity and performance. For each end, IL is associated with an underlay connection, such as MTN or fine-grained MTN channel, pointing to a remote network node, enable the integration of the underlay channels with the SRV6 programmability. What we have done here is 3 vendors, Huawei, ZTE, and FiberHome. They have already implemented the NIL with the MTN and FG-MTN underlay channels. So based on our draft in spring, so we can say that each equipment can be configured with NIL. So the SRV6 EVPN service interpretation is also achieved from the SPN devices, and it can demonstrate domestic performance, though the traffic testing will measure the latency and the jitter before and after the congestion both showed manual variation. Here's our team number and our document links. Thank you.
Next up, relay attacks.
Yeah, hello, I'm online.
Oh, thanks. Just give me a cue when you want the next slide.
Or maybe can I control myself? Is that possible? That will be quicker for me.
Sorry?
So it will be quicker for me if I can manage myself. So is it possible? Can you give me control for that?
Yes, but here we are. Okay. Now you can manage yourself. Yep.
Okay, fantastic. Yeah. Thanks very much. So I, Vyacheslav and Jan Perry, we worked on a tested TLS. We have been presenting this for several meetings. There are three ways to combine TLS and remote attestation. They are pre-handshake, intra-handshake, and post-handshake attestation. Pre meaning you do attestation before the start of the TLS handshake, intra meaning in between, and post meaning at the end or after the conclusion of the handshake itself. Our AD Paul requested that we do an exhaustive exploration of intra-handshake attestation. That's what we did. And the formal analysis tool that we used is ProVerif. The devil is in the details. As the title says, basically we have the TLS handshake protocol shown here, client on the left, server on the right, and client acting as the verifying relying party from RAD's perspective, and server acting as the attester. And the two, so basically there are two different keys inside the TLS key schedule, which are the handshake traffic secret of the client and the application traffic secret of the client. And the key here is basically that the handshake traffic secret is used to encrypt the handshake messages, which is irrelevant for the security. It doesn't matter whether you encrypt these messages or not from security perspective. They are not important. They are important for privacy perspective. And on the other hand, another argument here is that if you use attestation from the handshake traffic secret, basically the server is not yet authenticated at the point where it is derived, like the first three steps, client hello, server hello, encrypted extensions, the time at which that evidence is derived, at that point in time, the server is not yet authenticated, and thus it's not suitable for the attacks to be stopped at that point in time. I see that the timer is actually running faster than it should. So anyway, so the first four are the potential mechanisms are shown. The first four mechanisms are the base mechanisms, and the last three are basically combining these two, some of those, and we only see the combinations which are interesting, so as not to exhaustively explore, because, for example, attestation nonce is required in all, and we proved that basically all of them are vulnerable to relay attacks. And the conclusion that we have is intra-handshake attestation is not suitable choice for standardization, and we propose the post-handshake attestation, draft Fusati seed expert. And finally, basically, we will present the results at various working groups and research groups, as well as WOF, and pretty much you will hear every day about this. And we will have a site meeting where we propose a new research group on confidential AI. All of you who are interested are very welcome to that. And these are some of the resources from where you can get the information. Thanks very much, and I miss you all.
Yeah. Thank you. Yeah, I'm lost. Where are we? That's yours? Oh, okay. One moment. Maybe I jumped some presentations. One moment. Okay, let's go with the order, fast formation, and then maybe that's you, yeah? And then next follows the data tracker. Yep. All right, there you go.
Hello, everyone. My name is Luo Yuemin, and I'm from the Atomic Lab in HKUSC Guangzhou. And my project is FANTAST, the fast network formation for six-stitch networks at large scale. The six-stitch networks joint procedure follows a sequential process like the synchronization, the secure joining, routing establishment, resource scheduling. That means each step would only start after the previous one is complete. So forming a large-scale network with thousands or thousands of nodes would take hours. So in our solutions, we would form the subnetwork in parallel and merge the subnetwork with each other to form the unified network. So at the beginning, the DAC routes would form the main network. Some of them might not join the main network, and then random nodes are selected to fit the sub-DAC routes to form the subnetwork. And after that, they will merge with each other to form an unified network. So potentially, this method can accelerate the network formation at exponential rate. So this is how we form the subnetwork, and in our plan, we're gonna evaluate our method in simulation, and then we're gonna deploy them in hardware. And we also publish our code, simulator code in GitHub. You can get access it. Thank you.
Thank you. Okay, now one moment. I'll go to stop. Oh, yeah, exploring. It's up, yeah. There's some reshuffling, but it's almost the same order. Thanks. There you go.
Hello everyone, I'm Du Shenguang from Zhongguancun Lab. We will introduce our work on agent naming and discovery mechanism. It's a joint work from Tsinghua, Zhongguancun Lab, and CNIC.
Yeah, I'm Sui from CNIC. So the background is that right now agent is a really hot topic, and agent needs to interconnect across domains. So the problems are here too. The first one, how do agents from like different domains find each other? And the second one is how do we make sure their identity that they don't conflict? So the mechanism we define is like in the resolution layer. It's now for the discovery. We have another draft for that, but on the application we don't care about that. So here, the first we need to identify the naming, which we use the domain names as the stable identifiers for agents. And we also have the trusted resolution that we use the infrastructure, which gives an agent ID, finding its endpoint securely. And the last one is we have basic support for the discovery systems. So now the rest part will be introduced by Chen Guang.
We use 3 DNS record types. The SVCB record carries the main information, including the agent endpoint, version, and the protocol. The TXT record links some external metadata, and the A and the quadruple A record provide the basic connectivity for the agent for the clients that do not support SVCB. We keep the DNS simple and lightweight. We deployed a simple prototype using the code DNS. We can say that the client can register a new agent to DNS and view the agent information. The DNS can resolve the agent name to the endpoint. Thank you. We welcome comments, and we have a set meeting tomorrow. Please join us. Thank you.
Up next is agent interdomain routing. Yep.
Hello everyone, I'm Sheng Lin. Today I'd like to talk about the agentic interdomain routing. So, what is the interdomain routing in the AI era? Let's start with the routing analysis. With the multiple agents, the system can analyze and interpret the analysis, and based on the information, the system can generate the valid mitigation policies. The core models of the system can contains knowledge management, event reasoning, routing policy generation. According to the experiment, various models have achieved good performance for the event recognition. Across all identified events, the system can generate valid policies. Welcome to the follow next generation to domain routing protocol and architecture. Thank you.
Thanks. Up next. Yeah.
Hello, everyone. My name is Ziwei from Zhongguancun Lab. Today, I will introduce our recent work on BGP security, named Minimal Exposure AS Pass Verification against BGP post-ROV attacks. Let me start with the problem. AS pass manipulation and root leaks are still a major problem in today's internet. And the BGP SEC and ASPass are two main solutions to address it. But BGP SEC faces high computational overhead, and the benefit is quite limited during under partial deployment. ASPA can prevent root leaks, but it requires global publication of customer-provider relationships exposing sensitive interconnection policies. To solve this problem, we designed the minimal exposure AS pass verification. It decouples validations from disclosures. And it employs a validator assistant architecture in three phases: trust establishment, pass verification, and securing root selection phases. We evaluate it. The key results show that it has achieved better defense effect in several deployment scenarios. And the latency overhead is negligible. Finally, the conclusion, it offers a security, pragmatic, deployable, and less exposure path toward securing inter-domain routing. Thank you.
Thank you. Up next, we have AI agent protocol security.
Hello, everyone. So this project is started in 123 meeting in Madrid. So what we want to do is to study the identity, authentication, authorization, and privacy part for the AI agent protocol. So what we achieved, so last time we already developed a digital identity for the AI agent based on W3C DID, and we also developed a simple authorization procedure based on W3C VC. Then we started to study OAuth. So MCP use OAuth for authorization, so as A2A. That's enough for a single agent to call tools. How about the multi-agent system? So we think there may be more requirements for multi-agent system. If every agent in a group, in a task group, apply for access token one by one to the authorization server, it will cost a lot of signal link consumptions and also heavy the burden to the authorization server. So after analysis, we think the coordinator in an agent group can apply the access token for the group. So this is what we achieved this time. We started a MCP client as a coordinator. It can apply for the access token, the token request message, and the access token, we add some new parameters into it. And the coordinator can send the access token to another MCP client for it to call the tools. So next, this is our future plan. We want to study the security for gateway protocols, and also we want to develop some security tools. Any collaboration and comment is very welcomed. Thank you.
Thank you. Oh. Next up, E2E SRV6.
Thank you. This is Feng Yang from China Mobile. So we have people from China Mobile and H3C. And the background is that, okay, this is not the updated version. So okay. So the background is that today's AI agent service is booming, which brings the traffic pattern updates on this. The first one is before we have the human and the LLM interaction. Now it turns to the machine to LLM interaction. So the next is what we have to do is the interaction. There are dozens of interactions between the LLM and agent. So that puts requirements on the network. So there are three requirements for network. One is observation. One is quality assurance. The last one is the isolation. So we have an idea that some one solution with the overlay solution and the collaboration with the underlay network, which can guarantee the agent access services. So there's collaboration point is kind of ID which are subscribed by the user, and then it puts that user into that packet, and that based on packet, the backbone network will steer the traffic onto the correct path that can provide the service guarantee. So that's what I want to show. Thank you.
Okay, thank you. So the updated slides will be in the data tracker archive, but not in the Meet Echo. Apologies for that, but that's, yeah, we download most of the slides before 2 o'clock, and we do our best to keep up with all the changes, but part of the challenge for all of us. Next presentation is by, here we go, Asian Communication Systems.
Sorry. Hello, everyone. I'm Yu from China Telecom. So our project is the agent communication system for the network AI ops. So the problem solving is that we want to collaborate agent communication and collaboration framework that facilitates the coordination of the MAT agents and supports the intelligent automatic network operations and maintenance. So we have implemented the two functions. The first one is agent discovery. The second one is agent communication. And the first function, we build our agent DS problem solutions for the new ideas such as the agent metadata management. So we use the management of the key elements for agent, including the job responsibility and the codes of the conduct. Also, we build identity authentication functions rely on the trust root of the operator network. So the second one, we use a new design for the core capabilities such as the proposed a unified agent DS-powered gateway, integrating end-to-end resolution with the DAC guide orchestration across 3 functions layers, such as the resolution, merchant, and orchestration. We proposed the name-to-name resolution reserves a tagged agent by name for scenarios of the caller already knows which agent to invoke. Also, we proposed agent gateway for a pub and sub mode, which is a dual NIC architecture. Also, it is a unified agent gateway serve as the common entry point for AI agents, tools, and requests such as the MCP and A2A protocol. So this is our team's member, and also welcome the first newcomer in our team, Xin Song and Jiajun Li. Welcome to for the first IETF meeting in our team. Also, we have a side meeting on Monday morning. More details and presentation will found in Monday morning, and welcome to our side meeting. That's all. Thank you.
Thank you very much.
Hello, everyone. This is Chuan Sheng from ZTE, and our Hackathon project is HP1, High Performance Wide Area Networks. Thanks for the hard work from our team members. And we successfully achieved the objectives, including to check the HP1 state of art, identify methods for end-to-end HP1 service monitoring, and we discussed the HP1 deployment on topology for public networking scenarios. And we also tested the integration and the simulation of the HP1 functions. We also tested the RDMA performance and a quick-based optimization. Finally, we discussed requirements for HP1 service. So we provide the following hackathon results for 3 parts. First, we provide the simulation results and the performance comparison. We complete the quick-based implementation and provide the simulation results. We also provide the lab simulation and sanity testing, and we provide the 3 parts of hackathon results for the following backup pages. So we greatly appreciate the participants to join our projects. And if you are interested and you can get more information for the related documents, and you can get the materials in our GitHub. So for the last steps, we will define the IETF list to standardize to enable the deployment of HP1 services in March to May. And we also define the high-level HP1 services. So thank you for your time.
Thank you. Next up, the knowledge graph.
Okay, everyone. I'm Minzhe Qing from Zhongguancun Lab. Our Hackathon project is about using the knowledge graph to assist the network management. So we focus on the challenge from the network data that includes the unstructured, discrete, or heterogeneous network knowledge from the specific documentations and the logs and so on. So our proposed solution is that we can use the knowledge graph to model and correlate this network data. What we have got done is that we have built a knowledge graph with a large language model, and we provide a retrieval interface. First, we use the large language model to analyze the network hops and build a knowledge graph. In this process, the large language model has shown its capability to accurately extract entities and relationships from this knowledge. And we also provide a natural language query interface for the knowledge graph. So here is the web interface of our knowledge graph, which displays the entities and relationships and properties distributions of the knowledge graph. Based on this knowledge graph, we also implemented an interface where the operator can type their questions through this chatbot, and we can retrieve some relevant nodes and some relationships, which acts as context information for the large language model to derive the final answer. Here is another example. In this hackathon, we focus more about how to use the knowledge graph in network management, and the large language model is actually a good tool for the knowledge graph construction and interpreting. And maybe in the future we can explore agentic knowledge graph and its interface for network management. This is our team member, and welcome your comments through the email. Thank you.
Up next, PQ interoperability.
Hi, I'm Corey Bonnell, and I'll be talking about the PQC interoperability project. Just a brief summary on what we're doing. This is actually our 11th IETF that we met. Our first meeting was back in London in 2022. We're working on adding PQC algorithm support to existing X509 structures, keys, signatures, certificates, and then also testing interoperability on various implementations. We also want to gain implementation experience and provide feedback to the standards developers. So here's a list of some of the specs we've been working on. So we actually had an interim hackathon in January. The primary focus was on composite signatures and chems. A lot of excellent progress there, and also some work on the certificate discovery draft. What we've got done since then is we've actually pulled in the NIST PKI test suite into our PKI certificates repository. We also discovered some issues with ML-Chem verifiers, and we were working on actually some HOSI artifacts as well, and then additionally some more work on the certificate discovery draft. Still dealing with some algorithm implementation issues, some corner cases. We also did some cleanup of our PQC certificates repository to clean up some of the old draft algorithm artifacts. Here's the information that we have on the repo, and here we are with the list of contributors and our first timers this time. All right, thank you.
Thank you. Up next, Brett. Remote, maybe? Yeah, remote. Mike.
Yep. Hello.
Hi. You want to click yourself? Shall I click for you?
You can click for me. That's fine.
All right.
So this work is RATS PKIX evidence. So this is remote attestation. This is essentially a file format for HSMs, cryptographic hardware, to prove to an outside party that it's in a good configuration state. Next slide. So this is essentially one draft. The authors of this draft figured it was time that we had samples for the draft, test vectors for the draft. So we came into the hackathon with the goal of producing a reference implementation, open source reference implementation that could also produce the appendix for the draft. Next slide. So obviously the thing we did was just feed the TXT version of the draft into Claude and ask it to make a reference implementation. This was actually wildly successful. Next slide. It produced really clean, elegant code, which wasn't entirely correct. We did need to make some changes to it, but as you know, as a starting point for a reference implementation, this was extremely good. Next slide. So we've taken the conclusion here that feeding your draft into an LLM and getting it to produce a reference implementation is an extremely good way to check if your spec is clear and covers all the edge cases. If an LLM can produce working code, then your spec is presumably well written. So this weekend, in about 3 hours of work, we have 2 independent implementations going, and our source code's available, lives with the draft source. Thank you.
Thank you. I will almost ask any questions, but we don't have time. Okay, task discovery.
Okay, I wish I knew I can provide the draft to Claude and it fixes everything.
So what we're looking into is task discovery. The main idea is we looked into the traditional agent discovery. It looks something like this. So we have a discoverable entity, which is the agent. And the way we discover agents is that we have agent cards and we will go through a process of a search. So you create a task, you decide on the requirements of this tasks. Based on this, you go ahead and just search this repo of agent cards. So we said, is there an alternative way to do so? So this is what we're proposing. We're saying, okay, rather than posting agent cards and task owners searching through those task cards, how about task owners post their own tasks in the form of a discoverable object called a task card, and now agents are the ones doing the search. This way, the task owners and their tasks become a discoverable objects themselves. So what we did today is, or in this hackathon is, we developed a platform where you can post tasks, and we showed a quick demo where agents can actually look up those tasks, decide for themselves, use their own intelligence, LLMs, to decide which task is good for them. Next phase is, can we build this as a complementary architecture? That's what we're hoping for. Just final notes. So we wanted to shed some light on other possible discoverable objects besides agent cards. In this case, it's task cards. Those discoverable objects should be separate from the discovery vehicle. And we wanted to explore establishing the ticketing working group within the IETF for AI discovery. Those are some related work and drafts. We also have a side meeting tomorrow, AI ecosystem at 2:30 p.m. Please join us. Thank you.
Thank you. Up next, we have Bridging the Transparency Gap.
Good afternoon, everyone. So I'm Yuning from Huawei. So our Hackathon project is on distributed remote attestation. So the background is that in practice, remote attestation is often happening across domains. So usually we would have, for instance, separate remote attestation services in each domain. And different domains would have their separate or different policies, their own verify inputs. And this creates two recurring problems. The first problem is cross-domain attestation transparency, meaning that one domain may need attestation artifacts such as endorsements from another domain. And the second problem is that many verifiers may need multiple endorsements from different providers, and similarly, different providers may need to distribute those endorsements or reference values to multiple verifiers. So our goal is to provide a public or publication mechanism to solve this problem, where those attestation artifacts such as endorsements or reference values could be published, distributed, and reused in an efficient way. So this is the first architecture we developed where the distributed ledger publication would have off-chain attestation and verification. So in this architecture, the flow, such as attestation flow and verification flow, are following the current ROS architecture, while we would have the reference values and endorsements published to the distributed ledger. And we also have the second architecture. The difference between this one and the first architecture is that the distributed ledger would also have the registration and verification logic that is done through distribution ledger, such as through smart contract. And this way, the verification could be done in a more transparent way. We have also done our demo or hackathon developments through TLS attestation and Hyperledger Fabric. And if you're interested, please go to the corner and we could show you the step-to-step whole process. And thank you. We are looking for collaborators and feedbacks.
Hello, everyone. My name is Tianyu Cui from Zhongguancun Laboratory.
Today I will share our team's work about traffic LLM to enhance large language models for network traffic analysis. LLM application to the traffic analyst domain is limited due to the challenge of generalizing to heterogeneous traffic data and different downstream tasks and new environments due to the dynamic networks. So we built traffic LLM, which is a traffic domain foundation model to learn generic traffic representation from heterogeneous road traffic data. The framework contains 3 components. First, traffic domain tokenization uses pre-prompt and heterogeneous feature extraction to build training data. And we train traffic domain tokenizer based on BP algorithm to get token from traffic data. Second, dual stage turning pipeline separately filter with LLM with neutral language instruction and downstream task traffic to learn instructions and traffic patterns. Third, extensible adaptation with PFT split different capabilities into different external paraments, which helps reduce GPU resource and training time. Finally, traffic element has evaluated under 10 downstream tasks. And here are all codes, papers, data sets, and models, which are all available to the community. That's all. Thanks for your listening. Thank you very much.
There you go.
Hello, everyone. I'm from Huawei. I'm honored to share our project, Agent Networking Framework. It's difficult for bank application parties to interconnect with banks due to the following issues: non-unified interfaces, inconsistent protocols, incomplete service access. We developed the agent program and agent gateway program. We have implemented the intelligence open banking business based on agent and agent gateway and simplified the interconnection between application parties. In our simulation, the sponsor agent can provide users with the ability to query bank transaction records. UnionPay agent can share the differences between banks agent and simplify the interaction between the sponsor agent and different bank agents. The bank agent can return the corresponding user transaction information based on the request. In our demo, the agent has the following functions: agent information modeling, registration with the agent gateway, task breakdown and execution, discovering the agent through the agent gateway. The agent gateway has the following functions: agent registration and discovery, information synchronization among multiple gateways, agent traffic forwarding. This is the agent gateway page. This figure shows a sponsor agent how to query the bank account statements through the gateway. From this project, we gained valuable insights. Firstly, compared with traditional API communication, semantic communication of agents can provide stronger generation capabilities, reducing the adaptation cycles and costs. Agent gateway can simplify the access and interconnection of cross-organization agents. In the future, we will continue to optimize the framework. Firstly, agent gateway provides the agent protocol translation function to implement interconnection between heterogeneous platforms and protocols, efficient information synchronization between agent gateways to simplify the discovery and the interconnection of agents across large-scale organizations. The agent gateway provides the supervision and the audit function to ensure that agent communication is observable and traceable. That's all from my sharing. This is my team number. Thank you.
Thank you. Here we go. Pipelines.
Hello, everyone. I'm presenting CC Pipe concurrent and conflict-free pipeline for RPKI-reliant parties. And we focus on systematic barriers in the RPKI data supply chain. That is, traditional RPs block all updates from being distributed to routers until all data is synchronized and validated, delaying critical RPKI data updates. And our goal is to pipeline the RP validation run while preserving routing state consistency and mitigating introduce the router overhead. And for consistency, we utilize the resource allocation rule, and we aggregate some updates and extend the VRP cache maintenance strategy for router overhead. And there is some details of our design. The evaluation result shows CityPipe reduce up to 73% RP validation run latency and introduce the negligible router overhead. And to explore the standardization of CityPipe, we need more tests with more BGP router implementations. And this is our team members, all of us. This is the first IETF meeting for all of us. And our code is available at GitHub. Thank you.
Thanks. Up next. XMPP. Yep. There you go.
Hi there, I'm Daniel. XMPP is an IETF standard for federated instant messaging. Extensions to XMPP are not managed by the IETF, but by the XMPP Standards Foundation. We had an excellent extension that allows us to query what time zone a contact or server is in. The extension is actually from 2006, and responding to those requests is widely supported in the XMPP ecosystem. But displaying that information is limited or even non-existent. So for example, in the popular XMPP client Gadget, you have to go in like some menu and like dig very deep to find that information. So during the hackathon, two XMPP clients, Dino, a Linux client, and Conversations, an Android client, have been working on improving that a little bit. We refactored our code, added unit tests to the responding part, and added support for requesting the time zone information of a contact, and then also added display information of like what time zone a contact is in. And this is how it looks like if my contact is, if it's nighttime for my contact, I'm showing like a little warning in the chat screen so that I can think twice about whether or not I want to get in contact with them now. Thank you.
Thank you. Next is Ivy, I think. Yeah, it is.
Good afternoon, everyone. This is Yanxia from China Unicom. I'd like to share our project. This project focuses on the interactivity of the IVA model. The interoperable test bed is a most likely test bed. Two containers from China Unicom and Sienna placed as the inventory system. And one container from Huawei placed as the container rule, and the network is real hardware from Wuhan library. And we use the IVA model to get the real-time resource from the container. This is the IVA model and the draft we used in this project. This is part of the IVA system on China Unicom's orchestrator. They include the resource view and the resource management information. We have We have 11 members in total from 3 different companies, and 4 of us are from first-time hackathon. All materials were uploaded to our GitHub. Okay, thank you.
you. So not all updates will arrive in Meet Echo, but there will be in Data Tracker. So the latest versions of your slides will always be in Data Tracker. Next up is I2IC.
Yes, hello everyone. I'm Xu Wang from Sungkyunkwan University. Our campaign is 从재원 보루청, and our project is interface to network and computing functions project. So this project shows our hackathon poster. Our goal is to make a robot car that receives intent, detects obstacles, and avoids obstacles safely using camera and the radar through the I2ICF framework. Our I2ICF framework works in 3 steps. First step is user's intent is translated into network policies, and second step is 5G core delivers them to robot cars, and last step is robot car detects obstacles, stops or detours safely, and reports back. Our main goal is collision avoidance. So it is our previous framework. If the person is too close, the robot car activates the stop function. But for now, we added path planning as the edge server. So the blue boxes show the edit process. User intent is into the edge server, and path planning state is into the robot car and activate stop or detour function. So it's a demo. So we build a real-time perception to avoidance system, and the robot car's camera and radar measure distance, and robot car can also automatically plans on moving paths when an obstacle is nearby. So our next step is implement the intent translator and policy translator, and we'll also extend I2ICF testbed for next IETF. So it's our source code on GitHub and our demo video on YouTube. So it's our team. Thank you very much for listening. Thank you. Yeah.
Thank you very much. One moment, I will refresh the slides. Thanks. Let's see, next up, 5G I2N. Oh, sorry, I2N.
Hello, my name is Joseph Ang from Sungkyunkwan University. Our champion is Jeon Jung, and I'm going to talk about integrating I2NSF with the 5G networks. And this is our poster you can see on our table. And our goal is to make the edge-based security system in 5G networks with I2NSF. And you can see the detail in the internet draft. And this is the whole structure of our 5G I2NS system, and we are going to integrating the security system with the 5G core networks. And actually, the I2NS itself is the cloud approach, and it has the network security function on the cloud, so it can make the long delay due to detour security service via I2NSF cloud. But we try to use the edge approach, so we try to use the NSF inside the UPF, so to make the short delay due to the optimal security service path via the I2NSF edge. This is the whole structure of our testbed of 5G I2NSF. And what we learned is to make the 5G I2NSF, we learned on the cloud native environment. And this is a demonstration of what we've done now. And this is open source, and you can see video clip too. And our next step is to design and implement the 5G protocol procedure for the I2NSF, and especially to make the NSF be launched proactively before the security policy migration. And this is our hackathon team. Yeah, thank you so much.
Thank you very much. Next up, is this correct? It seems to be the last slide. It's probably an incomplete set of slides. I don't know. Not yours? Yeah. I think so, but only 2 slides. Is that correct? This is IPv6. All right, I will have a look. Okay, I'll have a look now. Where are we? I only have this version. I'll go to the next. Okay. Apologies. So something, we will fix it. So we go to the next presentation. Privacy preserving neural networks. Is that? Oh, yours. Oh, sorry. Again. Your IPv6? Yeah. Okay. I will go back and we go with the flow. Okay. Is this yours? Yeah.
Good afternoon. My name is Cao Qian from Zhongguancun Laboratory. I'm going to walk through a very brief demo about making SAV information visible with IPFix. What is SAV? It's short for source address validation. And it's a simple checking mechanism inside the network routers. When a packet arrives, the routers checks its source IP address and asks if the IP address is allowed on that interface. If not, the routers consider the packet as a spoofed packet and may drop it. This SAV mechanism helps to prevent source address spoofing attacks in the routers. But here's the question. The self-enforcement is a black box. What happens in the data plan is totally silent. So the operators have no ideas what just dropped and why the packets got drops. So we're going to open that black box by designing new IPFix information elements to export SAV information through a standard IPFix telemetry protocol. So we implement this hackathon project to prove the ideas. And here's the demo results. In the first data records, we see that on interface 5102, there are 256 packets that are dropped. Why? Because there's no allow list, no subrules in the allow list matches the interface. So we export all these subrules to show to the operators that the flow was dropped because it's the evidence. And in the next records here, we got to see more detailed information about the flow. We can see its source IP address, and it's trying to reach the destination IP address. So these two records together provide the operators with information about the attack surface, the victim, and the reason and the action taken. So that's it. Thank you.
Hello, everyone. I'm Kun Liu from Chinese Academy of Science. Today, I would like to introduce a privacy-preserving technology, fully homomorphic encryption. It is also known as the holy grail of cryptography. In traditional encryption schemes, once data is encrypted, we can't propose it in any way unless it is first decrypted. FTP breaks this limitation. It allows for direct commutation on data while it remains in the encrypted state. Here are some applications of FTP in machine learning. The first one is inference on MNIST database under homomorphic encryption. It takes less than 1 second to infer and recognize a single image, both secure and efficient. In addition to this, FTP is fully capable of supporting more complex deep neural network computations, such as the well-known ResNet, which is my second demonstration. As you can see, inferring a single image takes about 10 minutes. Additionally, directly transmitting encrypted data to the server faces a challenge. It significantly increases the communication costs. One method to solve this problem is transciphering. Here are some examples of transciphering from Trivium and the AES. If you are interested in discussing further about the application of FTP in AI, you are more than welcome to join our side meeting Tuesday at 11:15. Thank you, everyone.
Next up, Open Gateway.
Hi. Hello, everyone. I am Hu Tianshuo from Tsinghua University. Today, I will present our project, Open Gateway. It is an open source agent gateway for cross-domain agents in complex collaborative tasks. First is our motivation. Increasingly more real-world tasks require multiple agents to work together, such as smart factories. These scenarios bring challenges like hardware heterogeneity, workflow continuity, real-time response, and protocol translation. Most existing products struggle to meet these challenges. So this is our proposed solution, Open Gateway. It consists of 4 main parts: heterogeneous connectivity, task orchestration, working memory, and security assurance. This is our detailed project structure, architecture here. Current version includes 3 new capabilities for the gateway: working memory fingerprints request and enables memory reuse. The semantic router routes messages based on complexity, and the observability dashboard monitors all of this in real time. This is our project demo here. You can see the model output, and this is our monitoring dashboard. We are building this in an open source way. Task orchestration and working memory are already available. More functions such as agent registration, automatic protocol translation, and etc. are coming soon. We have also submitted an active IETF draft, and we hope to grow this work together with the community. Thank you very much.
Up next, Asian communication. Asian gateway.
Hello, everyone. Hope to be the last gateway today, whose name is not open. You can call it a welcome reception gateway. Yeah. Okay, so the problem is easy. So want to achieve cross-domain group communication skill-based routing, and also dynamic tool invocation and the registration, and also in parallel tool invocation, so you can simultaneously invoke tools to decrease workflow completion time. So what we did, we built a platform for agents, tools, and models to register within the administrative domain. And also we built gateway prototypes for information synchronization and grouping channel implementation, also MCP servers traverse. So yeah, so what we learned from the whole agent problem space, it covered many levels. So platform level, you need to manage and exchange trust across different administrative platforms. And the network level, you need to, if you want to achieve complex skill-based routing, you need to design the network framework, introduce network components like gateway to handling state, control policies, and manage traffic. And also the bottom layer is protocol layer. You need some protocol we design, I think, that can be handled by existing working groups. For example, OAuth to like handling authorization protocol and token management. And also next step for our implementations will be like introduce session protocols for better cost, and also maybe DNS-based discovery for interoperability and better scalability. Okay, contact us, please, and enjoy. I hope everyone enjoy the week in Shenzhen. Thank you.
One moment. Next is Thomas. I will do an update. I hope it's. I think, yeah. It shows a revision 1. I think it's. You can call it a success. Yep.
Hello, everybody. So this is about integrating Yang Push into Message Broker, so for enabling next generation network analytics applications. So this is not the first time we are here at the hackathon. So there was many preceding testing, mainly focusing on the publisher capabilities on the network nodes. So this time we are focusing more and more on the message broker integration itself. So we have multiple implementations on the publisher side, but also on the receiver side, also on the producer schema registry, message broker, producer, and consumer side. Everything is on GitHub. You will find the test results, the open source code, but also more details basically on the different verifications on the different system components. So please feel free to have a look in there. These are all the IETF documents related to that system architecture and how they are related to each other. So we are continuing here on the publisher implementation. So we have with Arcos another implementation which did most of the document implementation already. We're now also going forward with what we can subscribe. So besides the open config and the vendor-specific Yang models, now we have also the first implementation supporting IETF and IEEE Yang models for operational metrics, and you will see in the upcoming hackathons how we're going to progress in there. On the message broker side, here what we have achieved, what has been implemented. Noteworthy is about the NetGo's real-time data collection we have. Basically, all the different system components have been integrated there now, with, of course, the Apache Kafka integration in the schema registry and with the serializers, and we have with Sienna Blue Planet and Cisco Crosswork, the first two young message broker consumers where we are testing interoperability with. Now, in the last IETF Hackathon, we had some open items. Everything could be addressed. Many thanks also here to Paolo on all the implementation side he did on PMA-CCT, also to Michal on libYang. There were many changes in the area of Yang structure and any data validation. And of course, there were also extensions in the Yang schema registry and within the NetGo's data collection. We have new open items, so that we couldn't finish all the test cases we want to, so there are still a few things. As a teaser for the next IETF Hackathon, Maxence is working on a comparison on the different Yang libraries, the feature coverage we have. And we also intend to have some enhancements in the NetGo's data collection itself. And many thanks to everybody who collaborated here. If you want to know more, Friday, 9 to 11 at the NMOP working group.
Thank you. Up next is agent communication. I think we already got this one. Okay, there's been some reshuffling after the reload. Right. Yep, excellent.
So this is a joint work with my colleague Yang Fan from Alibaba Group and also Suresh Krishnan from Cisco. So we have published a draft. You can look at the link. It's about agent operation authorization. And we also have open source implementation. You can check the repository and you can try by yourself for the demo. So the problem we want to solve is that firstly, for the agentic application, especially for the autonomous agent, for example, OpenClaw, you cannot configure pre-configure the policy because the agent's behavior is dynamic. So we want to solve this dynamic policy authorization problem. Secondly, the agent delegation problem is not only the identity delegation, but also the intent delegation, because you cannot trust the agent pass the user's intention due to the hallucination. So we want to, the solution is that we want to band the policy, the agent delegation, and the user intent together for the authorization framework. So the solution, we divided the authorization framework into two different phases. First phase is the agent operation proposal stage. We reuse existing OAuth push authorization request. We extend that a little bit to put the user's policy, user's behavior into the PAR stage. We reuse existing Linux Foundation open policy agent to describe the user's behavior, the dynamic policy part. So this is a workflow. After the AS receive the push authorization request, the AS can determine whether can also redirect the authorization page to the user. The user can confirm whether this is the agent extract the user's intention is aligned with the user's original intention. The user can choose confirm or deny. The AS then can sign the user consent as evidence into the token. This can be used for audit trial and to analyze the security incident for the audit and other administration purpose. So in this demo, in this hackathon, we tried to set up a demo for the real user scenario. Here is agent delegate user to buy something according to the e-commerce platform. So you can try this. This is user consent stage. You can see what the agent want to delegate the user, want to do the what is the exact action the agent want to do. So the user can deny or accept. Okay, so that is the end of the presentation, and we will present this draft in tomorrow's OAuth working group, and we will also discuss that in the AI protocol set meeting, also tomorrow, Monday afternoon. Thank you very much. If you have interest, please join us.
Thanks. Next, we have. Yep. There you go.
Whoa, hit me in the face. Hi, everybody. We have been playing with knowledge graphs and Yang models for a while now on the clock. So what do we try to do with this one? We try to align CMAP and active and passive inventory, see how they can be aligned using knowledge graphs, or knowledge graphs can be used to view, see how they're connected, and in the case, surprise, surprise, sometimes they're not, how we can make sense of that. This is how the Yang models look. Complex, hard to keep track of. You got to keep it all in your head, right? Well, how can we quickly add the missing semantic knowledge and maybe recognize it? Well, we had a lot of fun building a UI. We created a UI to manage all of this stuff, browse it, graphical model-driven query, load it all up, convert it from Yang into RDF, all or shackle. This is what we got in the end. Probably spent too long on the UI, but we got a graph, and you can see here that active inventory has a relationship. You can browse on through it. For passive inventory, there's a relationship is missing, so we added the ability to add that relationship via the UI. This is what it generates, a set of triples. What are we going to do next? Well, we got to add in instances and show how we query. Thanks.
Thank you. There you go. Next up, Pegasus.
Hello, everyone. My name is Inchao Zhang from Tsinghua University, and I'm glad to present our work, Pegasus, deep learning framework on data plane. Exploring traffic diversity and encrypted threads in 5G, 6G, and cloud ecosystems brings significant challenge in network security. To address this challenge, we embedding AI inference directly into the data plane, enabling intelligent data plane for real-time autonomous traffic analysis. However, deep learning models demand intensive metric operations and high memory buffers, but data planes are optimized for simple flow tables and restricted resources. The core message is that flow-based abstraction vs computation-centric deep learning. To bridge this gap, we propose Pegasus. It's translating computation-centric deep learning into flow-centric data plane primitives, decomposing complex models into a sequence of the hardware-native primitives, achieving high-efficiency development via fuzzy matching and primitive fusion. We prove the prototype on our self-developed hardware platform, and achieving high throughput inference with minimal accuracy trade-off. Our future work focuses on distributed intelligence. We are aimed to leading the effort to define industry standards for intelligent data plane architecture. The source code and my email are as above. Thank you.
Up next, AOA. Already got this one? Okay. Continue. Threat. All right. Thanks. Yeah, I will make around which presentation we have missed. So there has been some reshuffling between, but everybody will give their presentation.
At this hackathon, I brought some Thread hardware to introduce that to new students who wanted a hardware project to work on. We had a small group at the hackathon this time, some old-timers, a couple of new students from the Chinese University of Hong Kong. They got up to speed really quickly, did some fun programming. This is a prototype hacking project from a guy from Huri, and AI is on everything these days. So this is an avatar with a motorized cube where the screen turns to face you when you speak. It runs OpenClaw to perform actions. The actions it performs use Home Assistant, which uses the Matter protocol, which uses the Thread border router to control all the things in your home. So fairly small tangential relation to Thread here, but AI is on everything. And here are our two newcomer students. They built a protocol for musicians to give audible beat signals. So when the musicians are playing, they can see a blinking light that's synchronized to keep them on the beat. So thank you.
Great to see how students are onboarded on this project. Thank you, Stuart. Next is Bron. Now we're correct.
All right, theoretically, I was last IETF, and I'm also last here. I had no friends, so I thought, well, how am I going to test if I don't have multiple implementations? I had a Perl implementation of DKIM2, which is the protocol for email security or email authentication. So I took my Perl and I got Claude to rewrite it. And then I asked Claude to write a Python implementation separately, and it also wrote that. They tested against each other. They came up with some inconsistencies from reading the spec and then worked on that. I got all of those working, and then I took the two most popular open source implementations of mailing list managers and added support for DKIM2 to both of them, which also passed all of their tests, including what I added to it. So in the end, I got Claude to write out what issues it had run into, working with those two and one person's example they'd sent me, and it came up with 19 suggested changes to the spec, all of which, other than the one that I made up myself, the author agreed with. That one we're still going to fight about. We're not looking for more friends, but if you do come along at 9 a.m. on Friday, that's when the DKIM session is. Thank you.
Okay, so we still have two presentations that were skipped because of the reshuffling. One moment. There we go. And first to packet scope. There we go. There you go.
Hello everyone, I'm Li Zhaoxi from Tsinghua University. I'm here to presenting my project, Packetscope, an LLM driver powered EPF for protocol stack defense. So what problem we are working on? Because the traditional network stack is black box, leading to two major pain points. The first one is difficult to diagnose. The performance bottleneck, like latency, are hard to pinpoint. The second one is difficult to defend. It's hard to detect, like modern tag is stealthy, stack rule will miss. So what we achieved in this hackathon, we successfully deployed Packetscope on our server. We deployed in the test network, monitoring and analyzing the live traffic. We validate the Guarder module. We use UPF with XDP hook to provide zero copy and zero latency data collection in the kernel. And we use long context reasoning, use LM to analyze this data. We build an intelligence defense loop. The LM will analyze the threat and auto-generate EPF filtering rules. Conclusion, our future work is we extend our tracing to application layer protocols like HTTP2 or QUIC. We want to build a cross-hole correlation for distributed tracing and analysis. That's our GitHub repo. You can follow our code here. Thank you.
Okay, thank you. Yep, got it.
Hi everyone, I'm Jing Zhao from China Unicom. Today I'm on behalf of my team to introduce our project IPv6 Network Traffic Monitoring and Analysis platform. Well, the purpose of our project is to design a IPv6 network monitoring and analysis platform based on the architecture and the metrics framework defined in our draft, providing end-to-end availability across home network, mobile network, IP-bearer network, and application domains, and validate the solution with typical use cases. So we develop an IPv6 traffic end-to-end monitoring and analysis platform, including two sub-platforms, the management sub-platform and the indicators sub-platform. So the key capabilities of our platform is to support multi-dimensional comparative analysis of IPv6 and IPv4 traffic across network regions and applications, as well as correlation analysis based on IPv6 traffic corruption, and provide end-to-end network quality monitoring and analysis, and support secondary level query responses with daily data resolution. So what we learned from this hackathon, we need to consider more fine-grained traffic monitoring method and analyze, understanding their associating challenges, and collect feedback on and support for our draft. Well, thanks for my team, and if you are interested in collaboration and have suggestions on how we can enhance our draft, please reach out to us. Thank you.
So, I don't think we skipped any presentation. This is your final chance. Raise your hand. No? Thank you. So, again, thank you for your flexibility and keeping all the presentations within the given time. Really impressed. It's 4 o'clock. We did a great job all together. Before I close, I want to mention two things. Tomorrow at 6 o'clock, we have the Hack Demo Happy Hour. If you want to present your project to the IETF community at large, please put your name or your project on the wiki. You can find the URL on the wiki. Put your name and your project on the wiki before 1 o'clock tomorrow, so we can prepare tables, flip overs, etc. That. And the other thing, I want to thank our sponsors, CNIC and ICANN, for sponsoring Running Code. They make this weekend, well, possible actually by catering, drinks, food, and all the organization by the secretary. Also want to thank the secretary. They do a great job for us. And that's it. Enjoy the week and see you through the week. And thank you. Let's close it. Yeah.